Hey, welcome to one of my coding sessions with Bangalang, our language that we're creating, which is low-level, explicit, procedural, compiled, and has this concept of kernels, where you can write a kernel that you can move the execution between CPU and GPU very easily. That's kind of the little feature that's a little bit unique. I think maybe it's getting less unique now. I think there are other languages that are starting to do this kind of thing, which are a lot more mature than mine, but mostly it's just a language to have a play with. And it's currently full of a lot of holes. And one hole that I want to try and patch up today is this recursive struct. We don't currently support this, not in any proper kind of way. And it's the way I do structs is they're a type alias, basically. So it's an assignment, just like everything else, where you're assigning to this variable, you're assigning this struct structure. Just like, so it'd be the same syntax as this, basically, except we don't put a type in here because this doesn't have a type. It is just, yeah, it becomes this. So to do that, I want to really improve the way that we do type resolution in this language. We have the, if I open up the grammar, in our language we have a concept of primary. We have three types of primary: left-hand side, right-hand side, and type primaries. The left-hand side and right-hand side, I think of as kind of the building blocks for left-hand side and right-hand side expressions. So like this is an assignment statement. So this is the left-hand side, this is the right-hand side. So this here is a right-hand side expression. This is the left-hand side expression, actually. It's, in this case, it's just an identifier, and it's followed by this. So this is the type primary. So this is where the building blocks is the type primary. And the reason I go over this is because just to say that there's three types of primary, and when we go into type checking, we have type check primary, which is a procedure which should take care of all of our primary stuff. But currently it doesn't actually really do type primaries. Type primaries are quite different. Left-hand side and right-hand side are very similar. But type primaries are different. At the moment it has this kind of early out where it says, you know, if it's a type, then just do this instead. Where really, you know, these are all the different types of primaries. You know, reference, negate, not, dereference. Most of them don't mean anything for types. But we do have some already that we've done here. We've got enum type. Looks like this just checks for duplicate members in the enum, which would be an error. This does nothing right now. I think we want to change this so that it does something. And then struct looks like it also just looks like for duplicate members. So I want to make type resolution happen in here as just a matter of course, you know, just like with other primaries, we go recursively through the primary, and whenever we find an identifier, then we resolve it. Values and types, identifiers resolve a bit differently. But that's what I want to do, because at the moment, if we go to ASTUtil, I think it's down the bottom. We have resolve types. And this is actually called from statements. So whenever we have a block of statements, we actually have two loops. This pre-loop, which does type resolution, and it also does imports, actually. And that's a big loop. And then down here is like the main loop where we actually type check the statements one by one. So this here is where we call resolve types, and it's just like this brute force, like it just recursively goes through the whole AST of the statement. And anytime it finds an identifier, it's like, are you a type? Are you a type? Are you a type? And it tries to resolve them. But it's very brute force and heavy-handed, and I don't like it. Also, the type aliases are handled specially. So I want everything to just flow through the same code paths, really. I want types to flow through the same code paths as everything else. So I'm going to cut that out. And also in the main loop, we have we were skipping type aliases. Actually, where do we use this? So we also use it in generation, because you don't generate anything for a type alias, right? It doesn't make any sense to generate code because assembly doesn't have types. Not in the same sense, anyway. So, I don't know, I have a feeling that we might be able to remove that sometime soon. So I'm going to put that note there. I'm going to take this out of here. So this is a nice, simple loop now. It's a very basic loop. The only thing special about it is it has this failures flag. So it will it'll continue to try to type check all of the statements, even if one fails. That's because then otherwise, if it doesn't do this, then the compiler will just give you one error at a time, which is a bit annoying. So now I can give you multiple errors. Okay, so that's sorted out. So now we're not doing type resolution. So actually, maybe if I go back here, I had this resolve types. Let's get rid of that. We don't want to use that anymore. And instead, we want to edit this primary. So we don't want to do this anymore. This is called type check type, which looks like it did exactly the same as the code I showed you just before. I guess I extracted it to here and then I forgot to delete it in the other place, but now I'm going to delete that one. Okay. But this also we need to modify. So this normally we go depth first when we're working on the primaries. So we go to the deepest node in the tree first, type check that, and then we work our way back up. But like a compound literal has a special way of handling its children. So we don't do it this way. Within the switch, it handles it. And that's also the case for these new types, like struct type, procedure type, enum type. Like you could see before, that it handles, the enum type is going through its children, and doing checks. And the children are structured in a bit of a different way. So I guess I'll make a complex primaries, which would be, no, not strings. I guess it's node types. Oh my God. So that would include the compound literal, the enum type, the procedure type, and the struct type. So we were saying if it's not one of those, so not slice.contains complex primaries, and what are we not containing? Node.type. Okay. So yeah, that should skip it for some more. Yeah, so enums are just identifiers, so I don't think there's anything extra we need to do here. Structs. So when you define a struct, see, I've got an example. See, here's an enum. So it's just a list of identifiers. So there's no types but there are types in a struct. See, we define types. Actually, we can probably go to the grammar and say, and sort of check where is the type primary used, because that's where we need to make sure that we are calling type check primary now. So it's on a declaration. That makes sense. So when we have a declaration, there's a type primary. So that's the one we need to do. Type primaries can be recursive, of course. And then the other places looks like struct type and procedure type can have type primaries. Okay. So struct type does have it. So each member is an identifier node. Yeah, each member is an identifier node which has data type information on it. So the way that's structured is that we do type check primary with the context member node dot data type. And we need more return. That should take care of that. But we have this special loop here because we're comparing each element in the loop to each other element in the loop. And for these kinds of loops, the outer loop usually skips the last element. But that would mean that we don't type check the last element since it's in the loop. So maybe in place of that, we can say if index is less than this guy, that should skip this inner loop for the last element, I believe. So that should work. So then now we have type check primary for structs. That's very nice. And procedure, so we don't have anything in here. If we go to procedure, we do have some type checking in here. We do the allocator. Yeah, that's kind of assignment stuff. I don't know how much to bring in. And this here is to do with the right-hand side of the assignment. So that's definitely not part of the procedure type. Actually, that's a good point. What's part of the procedure type? The allocator, I would not say it is. I mean, it definitely isn't. Excuse me. Silly light. So I think it would be this, We're doing the type node. Yeah, this is the type node stuff. So I think it's this loop here that we will cut out and bring into here. This is where we actually do the type checking. So this is actually just node. So this is the procedure type node. So the params type is the first child, and actually there is optionally a second node. So if the length of this is greater than 1, that means we have a return type, which is optional. And that should be type checked. Like so. Yeah, so I think we just, we basically just moved all the type checking into here. Hopefully that's okay. We'll see. We'll find out. What else? So the other thing is that we need to check what else a type primary is composed of. So we can have directives, that's fine. We can have references. So that's a primary type of a reference. We can also have something in brackets. So that's what we call a subscript operator. We can have dot something. And yeah, these things we've all taken care of, I think, already. So I think mainly it's reference and subscript. We just need to make sure, because in here, if I go, see, here's reference. And this code, like this is adding type information to the node, but this node is itself a type, so you don't add type information to a type. And this loop is checking what you can and cannot reference. When it comes to a type, you can make a pointer of whatever it is. If the thing you're pointing at, yeah, if the child node, this node, is a type, so let's write this code, I guess. If is type that child node, maybe we just return true, because it doesn't matter what it is, it's just always good. It's always fine. We definitely don't want to try and go into this code. And then subscript, is it the same thing? And this is doing a lot of complex stuff, which I think we would definitely want to avoid. Yeah, so subscript operator is like turning something into an array or a slice, and I don't think there's any case where you can't do that. Can you have a slice of a slice? I don't know. Let's not think about that too deeply. Okay, so I think that's that part. Now I'm wondering what else there is. Maybe we just run it and see what happens. Okay, so it looks like this is the only error, but we have this error still. So this is one of the places we did resolve types. So this is a call, type checking a call, and this really complicated, confusing code is for resolving placeholders. It is the generics code. So, and it's in the, so this is the parameter loop. So every parameter we type check what we're passing in. And once we've done that, then we can compare that with the types of the parameters. And if any of the parameters had placeholder types, then we create a map from the placeholder to the concrete type. And we add all those maps into this context here. And so this line is actually applying those to the procedure type node, so that any of the $sign, the placeholders like this. So this is the procedure type that has placeholders in it. So the reason we have this line is to resolve those, basically, to replace the $, with whatever, or $t with whatever it actually is. So I think now this would be type check primary, because now that's responsible for doing that. So let's see how that goes. Actually, while we're here, I see this, and it reminds me that there was something I wanted to do. I think we should do like this, because we have a lot of, or return. We have a lot of places where we return from this procedure, and we want to do this cleanup no matter what. So that's why we need this defer. So actually, anywhere where we have end, we should defer. So let's put this up here. Okay. And scope also uses it. Okay. So let's see how that goes. Segmentation fault. It's a good start. Convert SOA index. So this here is to do with SOAs, I think in the tests. Yeah, I was looking at this earlier. We have, so this is an example of an SOA. So it's an array of structs, we have this struct, and there's an array of 10 of them, but then we tag it with SOA, which effectively converts it to this, a structure of arrays. So it becomes a single structure where each member is an array. And we have this syntactic sugar here so that you can still access the members as if it was an array of structs instead of a struct of arrays. So you can do both of those and it works. It's just like a little bit of syntactic nice sugar, which is why I've actually tempted to remove it for now, because this here code is complicated and confusing, and I think it's also going to be challenging to convert to this new way of doing things. So I'm going to take this out. So maybe we have to comment out anywhere we do that. I'm just going to put a to do there, so we I don't know if that works on a comment. Like that. So we take care of it later. So did I removed that already, did I? Looks like, yeah. So yeah, let's just cut that out, and it looks like it was in one other place too. Where was it? Here. Okay, so now we have a bunch of errors, which makes sense because I tried to adapt things so they work with types, but I probably missed a bunch. Globals must return value from right-hand side. Globals 1. Well, globals has a bunch of type aliases. Yeah, so type alias. Yeah, so I did have this rule where, I mean, if you're assigning something, then this side should return the value. Otherwise, what are you assigning? But that doesn't make sense when you're dealing with a type alias. So I guess if we've type checked, we've handled the right-hand side, so we should be able to say if the right-hand side is not a type, then we do this stuff. What's this? That also we can leave out because we don't have data types on data types. So I think that's a simple fix. Cannot index type none. So none is like should be like a temporary type that we give things. Like this here. This is an assignment. We don't specify the type here. Like this assignment here. So we specify a type, but we can omit this, which is what we do here, and it's just inferred. The type is inferred from the right-hand side. But the reason for this colon to stay here, if there's no colon there, then there's no type information on the left-hand side. If the colon is there, then we add this none type information, which is kind of a way, maybe it's a bit of an indirect way, but it's kind of how we determine that this is a declaration, not just an assignment to an existing variable. So cannot index type none. Should we even get into here? Let's do a debug and see where we're going. So we're doing an assignment, we're type checking the right-hand side. And where are we? We're in globals line 4. So we're on this line. Yeah, so we have this here. So we type check the right-hand side, we go into the primary. We have not detected. We should have gone here. So what is node? Node is a subscript, and the first child is byte. Why is it byte? It should be, because before we go here, so byte is the child, right? So before we go into there, we should have gone into here, into type check primary, and then we should have gone into identifier. Ah, yeah, that's something we missed. Okay, I remember now. So in here we have code like this, which is what we do when we're declaring a new variable. No, not when we're declaring a new variable. When we find an identifier and we need to relate it to its declaration. That's what this is. So I think I need to take this, because we have two copies of this in this file actually. So what I'm going to do is say like apply declaration and put that there. So I think we need the context, and I think we can call it identifier now because we have more context here. We know it's the identifier. So that all becomes identifier, like so, and need to return a bool, which I guess means we need to return true at the bottom. So now when we go back up to, this is where we were, we just say apply declaration context node. Oh, and we need or return. And there should be one other place here that where the code is the same. Yeah, this is it. That's basically the same. Not basically, it is the same. So put that there. And then the reason we did that is so that we can amend this because, so first of all, we're checking that there is a declaration. There needs to be a declaration. Good. Now we apply that declaration to the identifier, which in the case of values means we add a reference if we need to, and then we add the type data and allocator to it. For a type, it's a bit different. So let's say if the declaration we found is a type, then we do something different. Otherwise, we do what we were doing before. And the thing we do different, if we go to util where we cut out this procedure, this is how we did it. This is how we apply the node. So identifier node, that's identifier declaration. So the declaration overwrites the identifier basically. Let's try that. Cannot index type, and the type is child type name, child type node. It's still none. Oh, wait a minute, I'm not sure if that solves that problem actually. Assignment, type checking an assignment. So the left-hand type node, oops, is none. Type check primary. That's right, we're not going into here. This is where we wanted to go. But should be, I don't think it should be, I feel like we shouldn't be getting to that point. If we go to the left-hand side expression, there's something we missed. The left-hand side expression is the other place where there's a data type. We missed it. So this is the left-hand side. When we do type check left-hand side expression, we're talking about this whole thing, which includes this, which we haven't done type checking for yet. We haven't added that. So in the left-hand side expression, maybe after that, after the declaration, we can say type check primary node.data type. Now we see none has not been declared, so we have a different error. Left-hand side. So I think, but I think we should actually not do this for none. If we have none, then I think there's nothing to do. So if that, so if it's not none, well, the value of it is not none. So that's going to take us back to where we were, isn't it? Has not been declared. Oh, so is this a different declaration? The identifier is string. Okay. Let's. But we still have cannot index type. Cannot index type none. There is another thing. I don't know if this is gonna. But there's another thing that came to mind, this here. Because if we go back to statements, the way that it did it was a bit different. You know, it did this for type aliases. I think for type aliases, we need to handle this a little bit differently. So this is the normal course. But if it's a type alias, which means that we have a right-hand side, that's what that condition means, basically. And the right-hand side is a type, then we put that right-hand side in. That's something that we need to do, but I don't think... Oh, maybe that did fix that, actually. I didn't think that was related, but it's into fix it and find other errors. Great. File descriptor has already been declared on line 18. So it's already, I wonder if it's because it's grabbing that one, like it's putting that in the identifiers and then it's coming down to this one and it's like, hey, you can't do it again. So in a procedure type, when you're in a procedure type, you should not, I guess it's like if this was here, then you would not want it to affect this. I think we might need to have some extra context to know that we're in a procedure type. And we don't want, like, if we do any assign, like this is technically an assignment. See this one, this is a parameter to a procedure and it has a default. So these are technically assignments. That's why in here, go to procedure, that's why we do type check assignment on them. But I think I want something like, you know, so we have within for, I want to have within procedure type, like that. So let's go type checking context. Procedure. So something like that. And I feel like this is maybe not the best, but what we could do is actually make a proc context, which is an anonymous scope. Obviously, we need to defer the cleanup. And then we can put that on there. And then whenever we go, that doesn't matter. That's just the looking at the program. So, whenever we go in, whenever we go deeper into the procedure type, now we know that it's a procedure. And I'm doing an anonymous type because I don't want, where's our, not globals, Linux. So if this is here, I want to be able to ignore the fact that this is a duplicate of it. And also I don't want this here to pollute the outer scope. I don't want it to pollute the outer scope. That's why I make an anonymous scope to prevent that. And this I want to use to prevent this from conflicting with this. So maybe when there's an assignment inside a procedure, or so the left-hand side inside a procedure, we don't care that something's already declared. If we're in a procedure type, then we don't care. It's not great. But I think it might work for now. I think it's a possible solution, a simple solution. Let's try it. Okay, that got rid of a bunch of errors. Time val t. Now that everything is going through the same code, this needs to be a declaration just like any other. So it needs to have the colon. Otherwise, it's expecting this to be a known value. Well, how did that came out of nowhere, but okay. $sign any int has not been declared. So $sign any int is so it's a type within a procedure. Within a procedure type, there's a placeholder. And in that case, it's it's never going to be declared. If we wanted to do like x any int, which is valid. We can do that, declare a variable with that same type. At this point, it does need to be declared. We shouldn't allow, like, if it was like that, that's not allowed because this does not appear up here, so it doesn't get resolved at the call site, and this should throw an error. But if it's like this, yeah, but this should, so this should be declared, this should not. So I think if we don't find a declaration, and we're within, not AST, context dot, if we're within a procedure type, oops, and the identifier is a placeholder, I think we just say it's all good. Yeah, this is all doing stuff with the declaration, but we don't have a declaration. Okay, let's try that. Recursive struct has not been declared. This is expected. This is the issue that we need to solve. So yeah, it's type checking this and it's getting to this and it's like, hey, I don't know. I haven't seen that before. Because it's only like right at the end of type checking an assignment that we actually put this in the identifiers. So it's not in the identifiers yet. Which is good in this case. It will prevent that. We'll say, hey, you can't recurse. It's not the greatest error. Like it could say, you can't do recursive structs. The reason you can do this is because then it's just a pointer. It could be a pointer to anything, which means it's just 8 bytes. Like if you try to calculate the size of this struct, it's impossible. You'll get infinite recursion. But with this, you can stop at the pointer and just say, well, that's 8 bytes. No need to know what that is. Could be anything. So that's why we need to have a pointer. So we might need to add something where we say like, hey, if we come across a pointer here, then it's all good. We also can do something like this. So struct A equals struct AU64 member is a pointer to struct B, and struct B is the same thing, but it's struct A. And that one could potentially not be a pointer. So struct B holds a struct A, and struct A holds a pointer to struct B, which is fine. So this is kind of like a circular reference between the structs. So if I run that, that's probably, yeah, it's also going to say, hey, I don't know what those are. So I think let's continue with the same kind of method. Did I? Yeah, I put that in there, didn't I? Okay. That's good. We keep that. Let's get rid of some of these. Identifier. I don't know which ones we need to open anymore. What were we even doing? Yeah, so recursive struct. So I want the context. That's what I was trying to get at. So we have this within procedure type. So let's have within struct type. So what I'm also thinking is that we also need to prevent circular references. So this should not be allowed. And we need to be able to detect that, that A has a B in it and B has an A in it. Because then again, just like this, you're going to get infinite recursion when you try to figure out the size of this or something. So we should be able to prevent that, and it should be able to say, hey, you can't do that. So we kind of need a path. When we start type checking a struct, we need to record like which aliases are we using. So, okay, it's a struct A, and okay, that has a struct B in it. And then when we're here, we come back to struct A and we're like, wait a minute, we shouldn't be able to do that. Now, I guess actually that might be handled right now. I think that could be handled right now just by the fact that it tries to find struct B and it can't find it. Like this line should be legit right now. Okay, let's just go with that. So the main thing we need to know is, are we type checking a struct? And if we are, and we come across a reference, does that mean we just don't bother type checking what's below it? I guess so. Whatever this is, we ignore it. So we have within struct type, if we go to primary, I hope we can just ignore this. I mean, it's actually not the best solution, because if we use some name that really doesn't exist, then when we get, and we don't really type check that, then when we get to generation, it's going to throw an error, which is not great. You never want an error in generation. You want to catch it first. But I think this would be good progress. It's in the right direction. I think to solve that problem, it's kind of why we need, I think maybe I mentioned in the last video, we could do deferred type resolution, so that these don't get resolved until you try to use the type. And by that time, everything involved in it needs to have been declared. And that kind of solves it. But one piece at a time. Maybe I'll open the to-do and say deferred type resolution. Yeah, I think that's something that is needed. But for now, I think we can do something similar, like when we go to struct type, then we can say, okay, we are within a struct type, and we can defer. Well, no, we don't want to just defer and make it false, because we could be within a nested struct type. And we have these returns, so we might actually need to say like we might have to do something like this. So we save it, we set it to true, we set a success flag, which we assume is true, which I don't like the sound of, but that's okay. We set it to false if something goes wrong. This also could go wrong, so if not, success equals false. And then at the end, we return success. No, that would skip that. We don't want to change that behavior, so I think we should say like if success to return false. So then, whoops, did I get that to? So then it only returns if it's false, and if it's true, then it continues on to that like it used to. But then the idea is that after all is said and done, let's reset this to what it originally was. Okay, so now we know that we're within a struct. And when we get to the reference, so the tricky thing is, because I said, it does it depth first in the AST, so the reference is actually the parent of the thing it's referencing. So first it's going to go in here. So we could either add it to the conditions to say, hey, look, don't do this. I think maybe I'll just make another condition up here and say, if we were within a struct type and the node type equals reference, return true. So yeah, so we just say, hey, it's all good. You don't need to check. Don't look behind the curtain. That's the idea. When there's a pointer, when there's a reference node, don't look behind the curtain. Recursive struct has not been declared. Huh. Okay. I thought I solved that. Let's go back to identifier. Let's have a look, see. So yeah, type check primary with the identifier, and this one here should be the reference, right? This is the reference. Oh, that's the Odin context. I was like, what am I looking at? Okay, within struct type false, yeah. But this type check primary is here. And we see here, we say within struct type true. Huh. So if I go to context here, within struct type false, maybe, no, we're not going into any procedures or anything. It's just a struct. So there's no like, we're not going any deeper. It's just a struct. We said we're within the struct type. Let's go here and check the left-hand side, see we're looking at the right thing. This is time val, which is apparently fine. Big struct is apparently fine. Interesting that this is the, oh, well, this is the recursive one, of course. Okay, so this is recursive struct. We go in, we find we're doing the right-hand side, which is a struct. We step over. So now context within struct type true. And we go through the members looking for duplicates. None found so far. And I have a feeling when I step over this, oh, it's in the loop. It's in the loop. Okay, that might work better. Something has not been declared. Struct B has not been declared. Okay, we're getting somewhere. So now if I take off this pointer, it should say, yeah, not been declared. And if I take off this point, and if I make that a pointer, Me has not been declared. Here. Right. I guess I moved all this code. Let's get rid of some of these files. I moved it all from procedure. And it includes type check statement assignment, which would add the identifier to the context. So when we're type checking a procedure, yeah, that's probably why this was here. It doesn't need to be, but we do need to do one thing. We need to make sure that we add this to the identifiers. I don't need that, I don't think. Yeah, all the parameters need to be added. So then when we type check the body of the procedure, it knows, like it can refer to the parameters. Otherwise, it couldn't, and it would do exactly this. It would say, hey, I don't know what that parameter is. There we go. Okay. It works. That's pretty awesome. So I'm tempted now to, I think there's already a blah in this file. If we say blah2 is a recursive struct, and blah3 as a struct A, let's say it's a struct A. So a recursive struct should be 8 plus 8 bytes. A pointer is 8 bytes, U64 is 8 bytes. And a blah3, a struct A, I mean, should be the same. These two should be 16 bytes. I'm going to put them right at the bottom so we can find them easily in the assembly. I just want to check that the assembly allocated the right size. Playground. Here's the default exit. So these are the two statements, 16 bytes each. Perfect. And struct B should be 8 plus whatever an A is, which is, as we just saw, 16. So it should be 24 bytes. 24. So it's calculating the size correctly. Yeah, that's pretty cool. I think we don't need those, but let's leave these here. Why not? And you couldn't do it this way around because it doesn't know what struct B is yet. So that's another thing where deferred type resolution would help. If you wanted to, like I'm a bit of a stickler for ordering. Sometimes I like things to be alphabetically ordered. In which case, if this was the structure, I would like struct A to be before struct B. And in this case, you could do that and it wouldn't be a problem. But I mean, that's very much a nice to have. It's not important. So the playground works. Does OpenGL work? I was celebrating too early. Well, I guess, you know, if, yeah, node is a type, then it won't have a data type. In which case, this would not make any sense to do this. Yeah. Wow, it was just... oh, that's still running. Better get rid of that so it doesn't work my computer. Wow. I'm kind of surprised that we got so far so quickly. I was expecting it to take longer. But I'm really happy with that kind of more unified approach. I think there's still some holes in there. There's some things that are not quite right. They could be improved. But this kind of thing I think is better done over time. If I tried to do it all now, it would not work. It's better to sort of let it sit for a while, and then as I try to do more, it will become clearer, I think, where the holes are, what needs to be improved. So for now, I'm happy. We can probably go back to the to-do. Allow struct member to be a pointer to a struct, but prevent recursive structs. That's what we did. There was also, disallow type redeclaration and require colon for type aliases. Well, we noticed that if we omit the colon, it doesn't work, right? It's like, hey, what's struct B? Oh, we also need to do the health check. I bet this is something where I've, done the same thing. So actually we wanted to try the playground. Okay, so the health check went fine. Yeah, so we can't, we need to have the colon. So that bit was solved. It also says disallow type redeclaration. I think that should be true, that it shouldn't allow that. Oh, interesting. Oh, maybe that was, sometimes, occasionally, there will be an error. I think it's in statements. Yeah, sometimes when it's doing this, like this, for some reason it's not set, or I think this should not be up here probably. It should be like within a procedure or something. That's probably what it is. But we'll leave that for now. But yeah, just occasionally that throws an error. I think that's probably what that was. So it's actually fine. And now it says what it should say. Struct B has already been declared. That is true. So this we can cut out. Better type checking for type alias import. I think import, did we add a to-do? Because, so this pre-loop is just imports now. Actually, we have a bit of time. I wonder if I can, let's do this now. This is so dangerous to do something last minute like this, but I think when I type check the call, what I want to do, so here's a special case for type conversion. Then I want to make another special case. So if it's, I think I did something similar for link, which is another special procedure. Yeah, this is the condition to know that it's a link. So here we know that it's an import. So whenever we call import, then we should do the import stuff. I mean, this is getting kind of long now. Might be good to break it out into its own thing. Yeah, let's go make a new file, import.odin. Package type checking, and then type check import, which is a procedure, proco. Put our code in there. Oh, it wants 4? Come on. So we pass in a context. And I imagine a statement. A statement, really? Type check call? No, it's not a statement in this case. It was because it was in statements. So the beauty of this is we get to cut that right out. So this becomes super simple. We need a bunch of imports. What do we not need here anymore? We need OS, file path. No, file path we do need. Slice strings. Okay. That's become very simple. We don't need loading anymore, or source. But we should probably add that in here. So maybe this should just be the call node. But we do need, yeah, we need the name, but I'm pretty sure we need the left-hand side. I think in the call procedure, when we're type checking a call, we don't have that information. Maybe this is a bit more complicated than I had thought, so I'm just going to back that out and add a to-do. Move to call, something like that. Cut that out. While I'm at it, just make sure those imports are needed. Okay. But oh yeah, so we have a to-do for import. Better type checking your type alias. I think deferred type resolution kind of covers that, so I think we can cut that out. Yeah, okay. Happy with that. Thanks for stopping by. Have a good one. Ciao for now.